Hello, everybody. So in this video, we're going to discuss quickly one last detail regarding the buoyancy, and it can be considered as one of the applications of buoyancy, which is determination of the stability of floating bodies. So for a floating body on the surface of water, or any body partially immersed in the water, there is, or in a fluid in general, there are two centers of or two important points on the in the body. One is the center of gravity, which is the sometimes called centroid, which is the point where the mass of the whole body is affecting. This is considered the point where the net force of the weight is acting on. And it depends on how the weight is distributed in the system. So for instance, in this case, if you have a sphere like this, and there is a weight on one part of the sphere, then the mass or the center of mass will be shifted from the center to the bottom towards this point or this direction. So this is the first point. The second point is what we call the center of buoyancy. So it's the same concept of the center of mass, but it is acting or it is for the buoyant force instead of the weight. So the buoyant force acting on a body would be acting at a point, or the net force would be acting on a point, which is considered the center of buoyancy, and we give it the letter B. And of course the force acting for the center of buoyancy is acting upward, and the force acting on the center of gravity is acting downward. And the stability of any body floating on the surface of or floating on a liquid surface depends on the relative positions of these two forces. So, for instance, and one of the very important applications is the design of ships, because the stability of the ships depend on how the 2 points are located relative to each other. So the first there are a few cases that we're going to consider, which are three cases here. The first is if the center of buoyancy is above the center of gravity. This is a very good case, because in this case the system or the ship would be stable. So if it's tilted to the right or to the left due to the waves or anything like this, the ship will restore its original state, because this is pushing downward and this is pushing upward. So it's going to restore its stability easily. There is another state where the ship would be stable if the relative positions of the center of mass and the center of buoyancy, and of course this is called B dash because the original center of buoyancy should be in the center if it's a symmetric shape like this. But when it's tilted, the center of buoyancy is shifted to the right because it's tilted to the right. So from the relative positions of the two points, we can find that there is a moment that's going to be generated due to or because the 2 points are not on the same line. So the gravitational force is acting downward at this point, and the buoyant force is acting upward at this point. So the net moment is going to be in the direction of restoring the stable state of the ship. So in this case, this is called a stable state of the ship. If the relative positions is in a case where the G and B are like in this figure, the net moment of these two forces is going to be in the direction of turning the ship or overturning the ship. So it's called an overturning moment. So the net force or the net moment is going to act more towards rotating the ship. So this is a state that's an unstable state. So this is a very important thing that has to be taken into account when designing ships, because this dictates whether the ship would be stable or unstable in case of having forces that tilt it to the right and to the left, which is a very, very common thing for ships. If especially if it's sailing in the ocean, it's going to be exposed to waves and things like this. So in storms, so in this case, the ship has to maintain the stability very, very well to prevent sinking. And this is a video of one ship that is being launched for the first time, and this is one thing that is that needs to be planned for properly, and there are a lot of precautions that have to be taken to make sure that the ship is stable. So you see it's being pushed by its side, and then it falls into the water, and it tilts a lot. I mean, if you look here, you see that it's tilting a lot, and you might think that it's going to sink, but because of the design of the ship to have the moment to be a restoring moment, the ship can restore its state and go back to the original stable state. So this is the last thing I want to discuss here or mention here, and this is the end of what we cover in chapter 3. And inshallah, in the next chapter or next video, we're going to start the next chapter, which is about the fluid dynamics. So we'll see you then, inshallah. Goodbye.